Welcome, everyone. This is Mike Gibbs, and I am joined by Russ White. For those of you that don't know Russ White, he is an icon in the networking career. He and I both came from Cisco. He was part of that distinguished architect team, which very few people were on. I can tell you, whether it's his books, he's been a legend for what, 35 years in networking now, Russ? Is that about how long
30.
you've been involved?
30.
30? Okay.
Yeah.
So, Russ is one of those few people. I've been a network architect now for 25 years that actually has been in this field a little longer than me. I had that little diversion in internal medicine there for a couple of years. But other than that, and I know Russ is educated in a whole lot of other things as well as just networking.
Yeah. Well, hi. Thanks, Mike, for having me on.
So thank you so much for coming here. So Russ, I know you've been an architect and I've been an architect for a long time, and we train architects. And one of the biggest challenges I have from people when they want to become architects is they want to get hands-on. And they do lab after lab. They're configuring virtual machines. They're setting up their Linux things. They're working with Active Directory. They're learning Python. They're learning DevOps. They're learning SysOps.
They're doing Ethernet bit level stuff. Yeah.
Yes, exactly. And they're doing all this hands-on tech work. And I tell them that you can't learn how to be an architect by building, that you have to study the technology and learn how the technology actually works and learn how the technology fits together and learn how the technology affects an organization's business processes and learn how to design the business side of it. So, and that they can't learn it by learning hands-on. So you've been an architect for now. In fact, you started before the architects were actually existed, when they called us design engineers before they turned us into architects. So could you talk a little bit about the knowledge to design versus the knowledge to build?
Yeah, sure. So I think that a lot of the difference between a designer and an architect, and by the way, when we did the CCDE and the CCAR, this was like a year's worth of discussion. Like, what is the difference between an architect and a designer? Like, well, what does that even mean? And so where we came down to, I think, on that end of the realm was just business knowledge. Now, I have since then, I would say, it's a lot more than just business knowledge, but it at least starts with business knowledge. And I don't just mean business knowledge in the sense of, okay, I understand what the ROI is. Great. You know what ROI is. You know what the markets are looking for, blah-de-da-de-da. No, I think an architect needs to be able to push back on the business, on business level decisions, and have enough knowledge and understanding of the market that business is in to turn around and say, honestly, you don't want to build your network that way. You want to build it this way over here. Because if you build it that way, you're capturing yourself technologically in a place like you're dead ending yourself. You're going into a cul-de-sac. Don't do the cul-de-sac. Step out of the cul-de-sac. Yeah, I know you can't anticipate that business might go that direction in 5 years. That's not the point. The point is it might. And so, having that kind of foresight about the relationship between future business and future technology.
Yeah, and that's a critical component of it. I call it business acumen. But the key is to understand how that organization operates and understand the customer journey and how that organization is structured and, how market forces like the economy affect that versus competitors, and being able to tell them, no, don't do this. This pretty simple little proprietary thing that looks so simple and elegant, it's going to lock you here. Instead, make this architectural decision or this architectural decision. And that's setting them up for success.
Yeah. Even not just, I would even go further than to say about proprietary stuff. There are open standards. For instance, okay, I'm going to use something I hit on a regular basis. I'm going to use GRE tunnels everywhere. Okay. It's simple. It's easy to configure.
Yes.
Blah, blah, blah. But in 5 years, when you start rolling new products, that's probably not really where you wanted to start. I'm going to use BGP in my data center fabrics alone. Yeah, until you hit your first security incident, and then you might think twice about that kind of a decision from a business perspective. The technology might be simpler no matter what it is, It's not the question. The question is, where does it take you business end?
Yeah, and I completely agree with everything you're saying there. I typically deal so much with cloud technologies right now versus traditional. And in the networking side, it was okay. Here we've got the standard protocol. It works for everybody. Maybe this is a better choice. Maybe it's not based upon the business needs. But it's like if you choose this, then you automatically can't have a high availability situation because you're stuck on a single cloud. Then you can't use
Right.
these tools from another. So there is that. But I agree with you. But it's that ability to push back on the business and be that trusted advisor for the business and be able to say, yeah, I think this is going to help you. Or no, I don't think this is going to help you. Or this is all hype right now, but there's no substance to it. That to me was one of the major differences.
Yeah. Yeah, that is definitely. And I think the second difference, if I were to lay out differences between design and architecture, is simply range. It's just flat out range. And so designers need to know, to me, a lot about what can I configure on this box or on this implementation to do that. Great. Architects need to know what is the range of possibilities within this technology. Now, that leaves you kind of blind to implementations. I always said when I worked for Cisco,
Yeah.
don't send me to a customer by myself because I don't know any of the hardware. I don't know a Cat 5000 from a Cat 6500 I don't have any clue what you're talking about. I generally broadly know what those boxes are and what they're built for, but I'm not going to know this line card does this and that line card does that. It's not my job. And that's not my place. My place is to know I need to pull this particular feature set of these particular protocols together to solve that problem. Now, Mr. SE, it's your job to go find the hardware and then to push back on me and say, you know what, that hardware doesn't exist. You can't do that combination. And I'm fine with that. That's cool because my knowledge has limits just like everybody else's does. But range across many, many technologies, understanding SATCOM and optical and all that stuff, routing protocols and everything else. I think the range of the architect is far different than the range of a designer. So that's like the number two thing to me.
And you hit upon that something that's so important. And I initially I say, look, if you're a technical architect, for the most part, you're an engineer and you're focusing
Yeah.
on system design. But when you move into these bigger architect roles, like you call it chief architect, you can call it distinguished architect, you can call it principal architect, you can call it enterprise architect. I don't really care. It's so much at a level that now it's going to take us a team of 15 to 50 people. And we're going to need consultants from every single background. Like I've told people, I've never worked on wireless and I've never made an Ethernet cable. Yet I consulted to the majority of the world's largest internet service providers and banks. Because knowing which pins are available on an Ethernet cable is not going to teach me how to design, the backbone for a large enterprise. And that's kind of that place where I think people get stuck. They think if you don't know how to do this one thing, how are you going to know how to do the other thing? But to me, they're completely different and they're not even related in most cases.
Yeah. Yeah, oh, definitely. Yeah. And I would say that the range thing goes even to the point of being able to ask hard questions and knowing where things like, okay, intuitively, I know that if I do X, that's going to impact this application over here in some way. I may not understand all the details of that, but intuitively, I know there's a trade-off there someplace. I know that I can't build a data center fabric with 10 millisecond jitter, guaranteed less than 10 millisecond jitter across the entire fabric, port to port. There's going to be a trade-off. What's the trade-off? What am I looking for? There's got to be a trade-off. And I've got to go find it. I can't just sit there and go, oh, no. It's all good. It'll all just work. No, it just won't all work. No, you've got to find the trade-off and you've got to go looking for it, seriously digging in hard and deep to understand where there will be unintended consequences for every decision you make.
And that's one of the most critical and valuable things that's out there to learn is, architects can't have a technology preference. We can't fall in love with the technology. Architecture to me is very similar to when I used to practice internal medicine. If I give this medication, it will affect this system, but it will cause this problem. So is that a good trade? And if so, do I give another
Yep.
medication to go treat this problem, one other problem? And as we layer our technology on, problem one, problem two, problem three, it's all about, well, is the trade-off worth it? In some cases it is, in some cases it isn't. I remember when I thought mainframes were going to go out of style, back when we were using data link switching plus to go bridge this mainframe trade across an IP network, and I thought this stuff's going to go away. And then I realized what mainframes could actually do and what they were actually good at. And even today, mainframe spending's still going up for that reason.
Yeah, exactly. Yep. And the other piece of architecture that I don't think people emphasize enough or understand enough is just communication and people skills. I think that we tend to get trapped. I mean, there was this old cartoon I had on my desk many, many years ago of a person talking to their supervisor, and their supervisor was saying, you need to up-level your soft skills. You need to communicate better. And the person on the other side of the table was like, wait, I went into computers so I wouldn't have to deal with people, right? That's the way a lot of us feel. And that's just not the way it works.
No, it isn't. And I like to tell people, it's like, look, the bigger your career goes, the farther you go, the further away you actually get from the technology. You're in fact trading your IQ or your intelligence for your emotional intelligence, and all about what kind of a team can you build, what can the team do together, what can you lead those outcomes to? And it becomes, in the end of the day, you reach a certain level of architect and you're almost so far away from the technology. You feel like a person that buys lunches, dinners, drinks, takes people, becomes a psychologist to people, herds cats and every other thing other than tech. At least that's been my experience over the years.
Well, like, we hope we don't ever get there. Have you ever read The Soul of a New Machine? I think this is, for people who haven't read it, you ought to read it. If you want to understand the architect role, go read The Soul of a New Machine. And it's all about one of the first microcomputers that DEC built. And it's told from the perspective of a guy who's working with the guy who's a manager, but he's really an architect. And what he does is he runs around and he says, all right, these people over here are building that board. These people over now, I've got to find a connector that's going to connect those two things in a way that makes sense. And I've got to tell them their power budget is X and their power budget is Y. And they have so much bandwidth on the backplane or on the fabric or whatever it is in the background. And these people, you only get so much. And by the way, if you're going to use this, you've got to use differential Manchester or negative based or whatever. He knew all the places where things connect. So he wasn't not technical, but he was just at a different level of technical. He was just at a different place technically than the rest of the team was. They were all head down doing stuff. And as far as people skills go, the thing I always remember about this book was that everyone on his team said at the end of the project that he didn't do anything. They all thought they had all invented everything, and he had done nothing. Like, he had figured out how to work with the people such that they were convinced that they had solved all the problems and they had invented everything and put it all together themselves. Yet he's the one who was sitting in the background making it all work. But he intentionally disappeared himself out of the system. He made himself somehow behind the scenes so that people didn't think about him as being the important technical person. And I just think that's such a apt description of what an architect should do in the long run.
I think it is. And, it's interesting. So I had been a principal architect on IP multicast video solutions. And then I joined Cisco and I was part of the global team. And, I was there for about a month and I said to my manager, what do you want me to do? And he's like, keep doing what you're doing. You're going to lunches with people. You're meeting people. You're getting to know people. I'm like, well, okay, but what do you want me to do? He says, I have no expectations of you for 6 months. It's going to take you 6 months to figure out Cisco. 3 weeks later, he says, Mike, this is the most strategic voice project in all of Cisco, and I want you to take care of it. It was for one of the world's largest banks. And I said, you do know I know voice. And he said, Mike, you've been making a lot of relationships here, right? I'm like, yeah. And he's like, go call some of them. And I built this team. I'm writing emails. It's going up to the EVPs, and they're determining which resources. It finally made it to John Chambers at one point, the email somewhere along the line, because he was aware of it. And all of a sudden, I've got this team. And I'm leading this team. We're responding to RFIs, RFPs, RFQs, and then it was time for a proof of concept. And out of nowhere, the SE director says, Mike, I want to see what you're doing. And I'm like, okay. And he comes down, and I'm like, well, it's around 11:30. I got to take the team to lunch. We got to talk. We got to diffuse. I got to see who's offended, who's happy. He's like, interesting. And then it's about 5:30, and I said, Terry, I said, I hope you're okay with this. You can go back, I know, but I'm going to take them out for a drink. If anybody needs some help, I'm going to talk to them. And at the end of that, he pulls me aside and he said, Mike, he's like, you're an incredible architect. He said, you've got incredible leadership skills. He said, I watched you. And he said, and you were negotiating between all these people, dealing with the customer, dealing with this one, protecting this one, talking to this one's manager. He said, that's what I hope for all of our architects. He said, so many people are so busy trying to pretend to be the engineer when they're an architect role, they miss the big picture. And I went, oh, well, thankfully I did the right thing, because, that was the only way I knew how to work, and I had no idea what was expected of me. It's not that technical of a job, even though it's technical. It's sort of kind of a weird sort of thing.
Well, it can. I would say that it can be. My architecture role today is fairly technical, much more technical than a lot of architect roles I've been in. So it depends, but I think the key on the technology side is not to make decisions; it's to make scoping, and it's to produce possibilities, right? So for me, the technology role that I play is, okay, this is the problem we need to solve. Now let's talk about it. There are 5 different ways we could solve this. And I'm not going to tell you what the configurations look like. I don't really care about that. I'm not going to tell you how to automate it. That's not my problem. That's engineering's problem. That's deployment's problem, whatever it is. And it's not like I'm sloughing the problem off on them. I want to give them the space to do the work they're good at doing. I don't want to take over their space. Not that I couldn't sit down and write configurations for a lot of this stuff. Sure, it would take me longer than they would, blah, blah, blah. But the point is also I need to make space for those people to do their jobs. But one way I can make that space is to give them a set of possibilities, understanding that they're not going to know the big picture of BGP as well as I do and how the whole system fits together. And therefore, I'm going to have to scope the set of possible solutions and tease out the positives and negatives of each of those possible solutions and what the trade-offs are, and then hand it back to the team and say, now you make a decision. I'm not making this decision for you. I'm the architect. I am sitting here just helping you understand the consequences of the decision that you might make. And if the team runs with a particular decision, even if I don't agree with it, fine, cool, let's go. I've done my best to make sure that everyone understands the positives and negatives of every one of those possible paths. And by the way, I'm open to other paths, right? Somebody on one of the designers can make them up and say, no, I have a different idea. Okay, great. Let's talk about that. Now let's do the same thing. Let's put it in the process. Let's figure out all the positives. Let's figure out the trade-offs. And once we get there, then we can make a rational decision. And then let the team run with it. And then be there, of course, if there are, oh, well, I'm not sure exactly how this should be done. Cool. Well, I'll dig into the technology with you. I'll dig into the configuration with you. I'm cool with that. I'll even dig into the code and help you understand, read the code and figure out where. That's fine. That's cool. But at the beginning of the process, it's not so much about technical or not technical. It's about the type of technical. It's about the figuring out what the trade-offs are, figuring out what the scope of the problem is, nailing down the actual describing the problem, understanding it, understanding possibilities and stuff like that. This is another architecture skill is imagination. And way too much in the technical world, we just have a complete failure of imagination. We just don't have any idea what we're thinking about in terms of, I don't know. You build a carpenter a hammer, and they're going to use it 500 different ways you never thought of. And it's just imagining what that could be like is very hard.
Yeah. And it's more the creativity. And actually, I know where you're at. And yes, where you're at, you would actually be far more technical than if you were more in like one of the roles at like IBSG and the innovations team at Cisco where I was, where it's like, where's the tech? It's
Yeah.
all business. But
Right.
and I can, but where you're at a very technical company, and I know you've been at all kinds of them, whether that, but I can see it. But it's all about, why and how creative could you possibly get? I remember having a bank, for example, and the bank was saying we need to get our multicast timers to like 2-second failover. And they were going to do all these scary little things. And I remember sitting back with the bank saying, well, if you do this, it's going to cause this problem. If you do this, it's going to cause this problem.
Yep.
If you do this, it will cause this problem. Now, we got an OSPF domain. We can make you an MPLS-enabled backbone, and we can signal this, and we can do this, and that will work. And it won't have these scalability things. But now these are the kind of people you're going to need and the complexity they're going to have to deal with. And can you deal with that? And in many cases, it was like, give them 2 different architectures or 3 and say, well, here's the strengths of this. Here's your other option. You guys decide what's better for your business. This is going to help you scale better and be more agile. This is going to give you greater availability and security. What do you want?
Yeah.
Because it's about what are we creating? It's custom.
Yeah. And what kind of people you're going to hire. I think that's a big problem as well. Now, unfortunately, I think we have a failure of imagination there. We do a lot of, we could never possibly deploy that because our people just can't learn that kind of stuff. They're just not interested. I really think we should stop underplaying people so hard. Like, challenge them. Let them go. Let them learn. Give them a reason to learn. Give them new things to learn. Like, I don't know this whole attitude we have in our industry of, oh no, they don't have experience in that. We can't do that. Why not? Like, if you know the protocols, if you know the technology, even if you don't, you can find somebody to do the training. Bring them in, do the training. There are books, there are videos, there are things people can learn. And so I think we have a very strong thing against people learning, and that kind of worries me a lot of times when I look out.
I look for people with strong fundamentals.
Yeah.
And understanding of how they work and how to think. That's my issue. Because I know it sounds crazy, but that RFC 1925 that came out many years ago from the University of Old Farts or Society of Old Farts, where they said every technology is new again.
Yes.
Well, I mean, every time I look at something new, it's something that we dealt with 30 years ago.
Yeah.
It's just got a new name and maybe it's 2% faster. It's not new.
Yeah.
But if your fundamentals are good, and it's about learning. I remember at Cisco, me and Howard had a PhD in theology, interestingly enough, and I was a medical professional coming from an internal medicine background, and we designed the reference architecture for all of Cisco's healthcare clients. And it was, here's the key: get people from diverse backgrounds, get people from a wide variety of educations outside of technology. Get people that understand life and build your team out of this one. So you've got maybe a theologist. I think you have a PhD in theology like he did as well. Maybe you've got a medical professional. Maybe you've got someone that was a soldier that knows how to deal with things under a crisis. Yeah. Get good people with good, strong fundamentals, and they can learn anything, and they all think differently, so they solve problems more creatively.
Yeah, and that I think you just said RFC 1925 Rule 11, which is why I call it Rule 11 Academy, Rule 11 Reader. I'm like a big fan of Rule 11. And as a very specific example, 20 years ago, we had frame relay. For people who remember frame relay, frame relay is a point-to-point technology. How did we solve frame relay broadcast and multicast? Well, we had an idea of broadcast and unknown channels and on the network replication. Then we came out with ATM for whatever crazy reason. ATM was out there, and it had broadcast and unknown. Well, guess what? The BUM network in broadcast unknown and multicast in ATM works identical to the one in frame relay does. Technically, there's different bits and different protocols, but the basic functional. And then, Dino Ferranici did Lisp, and he needed broadcast and unknown. Well, guess what? It's the same thing as ATM. Oh, and we have EVPN, and it does broadcast and unknown. Well, it uses the same basic concepts and ideas that frame relay used. These are not new. Like, this stuff has been invented 5,000 times, and we just call it different things.
It has. It was very interesting. I saw, and he was a very smart person. He was all excited by an AWS virtual link, how they could create like a virtual link across their network, and He was new to technology, so he was excited by it. And I actually knew the guy, so I called him. I'm like, well, this thing that you find interesting, this virtual wire. First, we had ISDN where we had these switch virtual circuits, and then we had frame relay, and then we had ATM, and then we were pushing across with BGP with that RFC 2547 VPN, and then we had VPLS, and this is just the same 20-year-old thing that we were talking about for the 20 years ago.
Yeah.
It's just a new name.
Yeah. And I think that's the key to understanding technology quickly, honestly, at an architecture level, is I actually don't need to know the bits on the wire about how EVPN multicast works. I don't really care. I just know that it works largely the same as every other broadcast and unknown and multicast channel I've ever encountered in my life. So I can look at it and go, okay, here's this problem. I know broadcast and unknown needs to solve this problem. I know that that was solved doing this 3 other times. Therefore, I'm going to ask questions to see if that's the same solution they used, or if they've actually been a little creative and come up with something different, or if there's a twist on it, right? It may be close to the same, but it's a little twist, and that's cool. And that allows you to say, okay, I know enough about this technology now to design to it. Now, again, if you want to know what the features are on a particular line card or a particular router on EVPN, you're going to have to find somebody else, because that's not what I do. But if you want somebody who can lay out how to build an EVPN network, cool, I'm here, right? And that's the difference, is that, and then when you get to that point, you think, okay, I have 5 different technologies I could use. I need to build a virtual overlay, for instance, in my network to solve a set of problems. Okay, I have 5 different technologies I can use. Now, what are the pros and cons? Which one's going to be great greenfield? Which one's going to work brownfield? Where can I transition? And once you understand the technologies at that level, it just becomes so much easier to lay out design and think about it and lay out an architecture that makes sense. And again, going back to the beginning, I don't want to just solve the problem as it exists today. I want to go to the business leaders and say, where do you plan to be in 5 years? What new products are you planning to offer, or would you really like to offer? And now, which of these ideas will push you towards that goal and allow you to be flexible in this market space that you're in, rather than trapping you in a cul-de-sac? I think that's where the architect has to play at that central point right there.
Yeah, and I agree. And unfortunately, you can't get that skill by building it. This is a deeper level. This is the thinking about the tech, thinking about how the tech works, thinking how the tech interplays. And, we're talking networking, but it could be cloud architecture. It could be AI architecture. It could be anything. We're not really, we're at that level where we're thinking about the big picture. We can't zoom in, because the second we zoom in, we miss the big picture. But it's that trade-off. What do I give if we do this? What do we lose?
Yeah.
And I deal a lot of times with people with cloud architecture, and they don't coming to us, they thought they learned to code, and they don't realize that the network is part of the cloud. They don't realize that the cloud is somebody else's data center, because the training of today is basically giving a name of something and how to configure it, which the training of yesterday, which is, here's this tech thing. Here's how this tech thing works. Here's why you may or may not use it. And now here's how to configure it. But without that understanding of how it works, what are you architecting? What are you tuning? I just don't get it.
Yeah. And in fact, I almost think there's no such thing as a network architect per se. That's kind of strange to say. If you're an architect, you may have a focus area. Like, I focus on network technologies, but that does not get me off the hook for cloud. That does not get me off the hook for security. It does not get me off the hook for privacy. It does not get me off the hook for business and data engine, enterprise architecture. I have to know at least enough about those things to know that first of all, I need to be able to speak that language, because I'm going to have security people in the same room. And the second thing I need to do is I need to be able to say, all right, if I do this on the data transport side of things, what does that do on the security side, right? It's, again, 1 protocol versus 2 protocols in my data center fabric. Seems like a very technical discussion. It's actually a security discussion and a manageability discussion. It's not a technology discussion at all. It's all about automation and maintainability and security and all those things that are really outside of network architecture proper, if you even want to call such a thing in existence. So that's I think a major point to make is you don't get to specialize in architecture the way that somebody who does operations or something like that might get to do.
Yeah, and that's the key. My friend David Lithicum and I talk about, he's actually the architect of our AI architect program. And, it's the same job I've had. When I was a network architect, I was still focused on the big picture. When I was an enterprise architect, I was still focused on the big picture, but I had to wear better suits and I had to attend better meetings. And now I was more the business side, but it was still the same thing. When I did security architecture, well, there's no security without the networking and there's no security without the user. So it all turns into the same job.
Yeah.
I think the only difference is, realistically speaking, where your core competency is.
Yep, that's exactly
To be a network
right.
architect, you need to know more about the network. To be the cloud architect, well, it's kind of knowing the network and the data center now, which means you can't be as deep in either one. You're a security architect. Well, you can't do security if you don't understand systems. You can't do security if you don't understand networking. You can't do security if you don't understand the way the work is done. So they're all so similar.
Yeah, yeah. And I would say people have this view that you can only be so deep. If you go deeper in security, you can't be as deep in networking. At this level, I actually don't agree with that. I think at this level, you can say you are a 6 out of 10 on networking. You can still be a 4 out of 10 or a 5 out of 10 in security. You may never be a 6 or a 7 or an 8 out of security, but you can still, so, maybe you're an 8 out of 10 in networks and you're still a 6 or a 7 out of 10 in security. The key is time. The key is just time. The longer you do it and the more you are intentional about learning new things, the more you're going to increase not only your range, but your depth at each of those ranges, at each point in that range. And I think that's something we have this view in our world. Was it jack of all trades, master of none? No, that's not true. Jack of all trades, master of one.
Level.
Yeah, right. Jack of all trades,
master of one is
one.
architecture.
Right, exactly.
Now, if we were trying to be that distinguished engineer where we had to be an expert on one thing, now at that point, that person needs to be a 10 out of 10 or an 11 out of 10 at their one thing.
That's right.
And they have to be. And we architects need those experts, the person that's lived, eathed, and breathed that one little thing. And they're very valuable in this world.
Yeah.
But architecture, the specialty is architecture. The specialty itself is how do we optimize our client's business? How do we give them areas for growth? How do we make them more agile? How do we do this? The technology is kind of the subspecialty. And we can be better at security or better at networking, but we still have to understand the other components of what they are and build a network of people that are experts that can get us to our goal. That's what they focus on all day.
Yeah, I don't think we do as well with understanding how to build networks of people and how just to deal with people as much as we should. And you mentioned before, I have a PhD in philosophy. It's from a theological school. And people are like, why would you want to do that? Because understanding things like the nature of truth and just understanding these types of problems and the history of philosophy has really helped me to relate to people better. And here's another weird thing about my past. I did art in college for a couple of years and I did music in college for a couple of years. And okay, how do you do really good diagrams? Well, you don't just buy a tool. This is what we do. I see it on Twitter and stuff all the time, or X or whatever it is. Oh, what's the greatest tool for building network diagrams, animated? Well, the greatest tool is the one you know how to use. And the greatest tool for building network diagrams is actually your brain knowing how to present information in a visual way. And that's just a skill you have to learn over time that is so underrated and so important in the architecture world.
Yeah, I actually one of the things that as I was leaving engineering, I went and did an MBA, which gave me some of the business acumen, not enough. And then I started taking all these leadership and sales and executive presence and CXO role. That was the big kicker. But I was also giving 3 and 4 presentations a day and doing multiple executive briefings per day and showing up and presenting to the board and the C-suite. That's really where I had to be good because I now had a prep for my presentations. It wasn't like that sales engineer level, the SE level where I could just go to a meeting and I pretty much was good enough. This was the level where I had to really dive deep into something. So it was all that planning. It was all that preparation.
Yeah. Being
It
able to
was
tell a
there.
story, not just saying,
Yeah.
do this, being able to tell a story, right? About this is what happens if you do this. This is what happens if you do that. Connecting consequences to actions, unintended consequences, trade offs, being able to connect those things in a way that's visual and understandable so that people can get it as quickly as possible. I think that's a real skill, and it's very much something important in the architecture realm. It's kind of important in the designer realm, but I think architecture, it's even more so than it is in the designer realm.
It is. And, this may sound a little strange, but I've trained people from all walks of life to become architects, and they work at pretty much all major companies at this point. I think the easiest people I've ever trained to be architects are actually sales reps. And they're the first to be hired. Now, you would think, sales reps don't really know the tech, but they know how to tell a story. They know
Yep.
how to ask the right questions. They know how to present. They know typically how to build a team. They know how to communicate. And then it's just filling in the technology gaps with the business things they're already familiar with. And a lot of them become the easy time of it. But so I always found that to be the interesting thing. But architects come from all walks of life. You could study art, you could study medicine, you could study anything. It really doesn't matter. And that's one of the
Yeah.
things I've always loved about it.
Yeah. Yeah. Oh, yeah. Definitely. It's definitely a thing that again, for me, it's again, I go back to range. I go back to it may seem crazy. I mean, in electronic engineering when I was a kid, and I'm on X and people are asking me questions about Ethernet wiring. And I'm like, well, that's not the way the signal's modulated. And they're like, how do you know this? Because I did amateur radio and I climbed towers and I did stuff like that. And then, oh, how do you build such a cool presentation? Because I was an art major in college for a couple of years and you learn how to do illustration and stuff. And how do you know this about people? Well, because I have a PhD in philosophy, right? And so, it's this matter of intentionally over your life, not just doing the things that everybody else is doing, not just going, oh, well, I need to go learn this new bit level pattern or whatever it is on the wire. And that's just not where architecture is. That's just
No.
not where you need to be.
No, it isn't. It's that outside the box. I used to get put on big crisis. If there was ever a crisis, Mike, you go deal with it. If like those kind of cap cases, anything that would be big like that, Mike, I just need you to go deal with it. And they were like, Mike, you managed to stay so calm under pressure. I don't understand it. Well, I said, either it was the 20 plus years of martial arts, or it was the fact that I was a firefighter paramedic in college and every
Yeah.
day was a crisis and I just got used to a crisis.
Yeah,
So you got a fire
exactly.
to put out. I wasn't too good of a firefighter because I wasn't good with tools no matter how hard I tried. So they kept me on the ambulance. But you get the point. It's like
Yeah.
life is cumulative. Take these
Yeah.
lessons, get people from a
Yeah.
wide variety of backgrounds.
Yeah. And in fact, I think there's something to be said for that you almost have to put yourself in bad situations in terms of pressure to get to the point where you deal with pressure. Like for me, there have been many different things, but being in the U.S. Air Force and being on the airfield and having an airplane full of people floating around above you, and if you don't get that ILS system fixed, they're not going home for night, right? They're being misdirected someplace else, or the plane could even crash if you don't do the ILS correctly. And there's a false lobe on that center line. That airplane could actually end up in the woods someplace, and people can die. You don't mess with that stuff. You've got to be good, and you've got to be right the first time, and you learn that that's just the pressure of life. That's just the way it is. You just have to go on and do it. There's no kind of, well, I'm just going to lay back and not worry about it or whatever. No, you can't. You got to own the problem. You got to go on and do it. So that's kind of I think that's a massive important point.
Yeah. And truthfully, when I hire architects, even if they're a little less technical, if I know in and they're going to walk in and they're going to own it and they're going to say, I have to get this right.
Yeah.
And they're going to do whatever they need to do in the background to get all the right resources there. That person's more valuable to me than a person with 6 CCIEs.
Yeah.
I mean, this is a person that solves problems. This is a person that I'm really concerned with.
Right. Yeah, that's exactly right. Yeah. So awesome. Yeah, I think all of that is true. And I think it's all really important for an architect to pick up all those things.
And I do. So, Russ, any new books you're writing out there you want people to read out there? Because you've written some good ones over the years.
Well, right now I'm actually working on my own training site just because. Why not?
Okay.
It's a networking technology training site. It's called Rule 11 Academy. And I am trying to find unique takes on everything I've ever taught in network engineering and basically say, even if you're just out of high school and you want to understand everything there is to understand about the Rule 11 way of looking at networks, right? The underlying technologies, there's no configurations. Well, I say that there are labs, but the emphasis is not on the configuration. It's on the operation. It's how things work. And there's no, let's go capture a packet and look at the bits. Don't really care. Really care that you understand that, for instance, BGP best path is non-determinative. Well, what does that mean from a design perspective? What does that mean if I'm thinking about using BGP to solve this problem, right? Those are the kinds of things I'm dealing with. So that's the big project at the moment. And there'll be a lot of soft skills in there as well as I go on. I think it's going to take me like 5 or 6 years to get through this material, but it's just I'm going to chew on it.
I totally get it. And we do something very similar. It's all about the underlying technology and how does it work and how does it fit together and how do you build a business case around it and how do you present it to the client and sell it to the client and communicate it to the C-suite. All those same things because, that's architecture.
Yeah, that's right. Yeah. And I would call this more of a network engineering, a high-end network engineering leading towards architecture training more than I would architecture training specifically.
Okay.
But, again, to be an architect, to me, you have to kind of have some specialty. You have to have some technical skill set. And for those who just want to do network engineering as a designer or whatever, you still have to know a lot of stuff. And so, yeah, trying to lay it all out there.
Especially those network engineers and those technical architects and those system designers.
Yeah.
Those design engineers, incredibly. Russ, I want to thank you so much for sharing your expertise with our audience. I'm grateful to see you. I haven't seen you since the Cisco days, so I'm thrilled that you're here.
Yeah, great. Thanks. And thanks for having me on. Anytime you want me to come back, we can talk about whatever.
Love that. So I will take you up on that. Thank you so much, Russ.
Thanks.